Good afternoon, everyone, and thank you for attending our fourth UK and Ireland VCF Enablement webinar. My name's Carl Bavington, and I'm one of the Solution Architecture Managers here at VMware by Broadcom. And today you'll be hearing from me and Campbell, one of our specialist solution architects about vSAN encryption. As I'm sure you've seen on LinkedIn, in the press, 10 days ago, we released the first major release for VCF since the acquisition of VMware by Broadcom. If you didn't see the launch event of VCF 9 on the Cube, I will post that later in the chat so you can catch up on that. There are many new features which will simplify the operation of your platform and reduce time spent administering your VMs and your containers and potentially your AI workloads. But today we're not going to go through those features in depth. Obviously, we've only got approximately 40 minutes to go through the topic. But I will post a link to a What's New in VCF 9 blog. So if you haven't seen those, which I suspect is unlikely, you'll be able to go back and see the major features of VCF 9. The other thing which I thought was worth calling out is the VMUG did a VCF 9 launch event webinar. So that went on for, I think it was 7 or 8 hours, consisting of many, many sessions. So if you weren't aware of that, go and have a look at the VMUG site and watch the replays. And finally, for anyone who stood up VCF 9 either in a test environment or a home lab using Holodeck, Holodeck has also now been updated to VCF 9. For anyone who's not aware what Holodeck is, it's a way to be able to build out a full VCF environment on a single host. So it's perfect for test environments and for home labs. And finally, we have released VCF 9 labs in our hands-on labs. So if you want to be able to go and actually drive and utilize some of those features and learn around the capabilities, then go off and have a look in the hands-on labs. And also, actually, sorry, next slide in. Just before I hand over to Ian, if we've now released the content catalog for Explore in Vegas. So if you have been lucky enough to be able to get yourself a ticket, and obviously the flights over to Vegas, then the content catalog is open. So go and take a look through that and make sure you get yourself into sessions. Regarding Explore on Tour, so obviously we've got it in Frankfurt, London, and you can read them at the bottom of the screen, but the London registration is open on the 9th of July. So make a note of that in your diary so you can secure your place as quickly as possible. I believe the cost is £150 and it's going to be at the Hilton London Metropole Hotel. So obviously put that date, the 9th, in your diary so you can secure your place as quickly as possible. And obviously that will include the usual food and drinks, backpack, and also the certification exam. So enough on that. So for today's session, feel free to ask any questions in the Q&A. We've got a panel who will try and answer those as many of them as we can. So on that, Ian, can you introduce yourself and take us away?
Thank you. Hello, everybody, and welcome to today's session, which is based on vSAN security operations. My name is Ian Campbell, and I've been at VMware for the past 7.5 years. I'm a specialist solutions architect, and my specialism is VMware vSAN and also VCF storage. I've spent the previous 25 years in and around the data storage industry, so I've got lots of experience dealing with data storage in the realms of virtualization. Okay, that's more than enough about me. Let's crack on with the show. Okay, so today's agenda, we're going to be understanding how vSAN protects data on disk with data at rest encryption. We're going to show you how to configure vSAN data at rest encryption and then describe the I/O flow from the guest OS to encrypted data that resides on your disks. We're also going to explore the ESX host boot up process when using encrypted disks, and very importantly, understand how new keys can be generated. We will also explore how vSAN protects data in flight with data in transit encryption. So here we go. So why vSAN security? Well, as you know, protecting data at rest and data in transit is vitally important to any organization to meet enterprise security compliance. vSAN offers both data at rest encryption and data in transit methods to ensure that your data remains secure. And it's certainly one of the features that we've had more and more of our customers start to deploy and use. From the telemetry data that we find that we have, the phone home data, we're seeing a massive uptick in customers starting to deploy and use these features. So again, hopefully by the end of today's webinar, you will have a better understanding of how vSAN security can help you increase and enhance your data security posture. So, okay. So let's see how vSAN encryption works. So vSAN encryption is native to the vSAN layer. It's actually built into vSAN at the HCI. It's configured at the cluster level, okay? And data in rest encryption ensures all the data that's stored on the vSAN data store is encrypted. And we'll show you how that's done in a moment. Data in transit encryption ensures data is encrypted as it traverses between vSAN hosts. So that means that data that goes between the hosts is highly encrypted. So you cannot snoop the data. It's fully supported on all hybrid and all flash vSAN deployments in both OSA and ESA clusters. And there are some differences between the way that vSAN OSA, which stands for Original Storage Architecture, and vSAN ESA, which stands for Express Storage Architecture. There is a few differences that I will highlight during this webinar, because yes, it's worth mentioning that ESA, with their data enhancements, it does make data encryption a little bit more efficient than OSA. We'll get to that point in a moment. So vSAN data at rest encryption and vSAN data in transit encryption operate independently, but they are both compatible with vSAN OSA. You don't have to use both, you can use one or the other, but of course, if you want to increase your security posture, then we would recommend that both are deployed. But you don't have to do both at the same time. You can do one, or you can do the other, or you can do both. It's entirely up to you. Again, it's a very flexible way of deploying data security. So now let's take a look at how vSAN data at rest encryption works. So data at rest encryption securely encrypts data using AES 256. There's a lot of acronyms within this webinar, so hopefully hopefully I'll explain all of them. So AES stands for the Advanced Encryption Standard, and it's a specification of encryption of electronic data that was established by the US International Institute of Standards and Technology, otherwise known as NIST, way back in 2001. So vSAN data at rest encryption has the following benefits. We can encrypt all the data residing on disk groups and storage pools, whether it's vSAN OSA or vSAN ESA, as you can see in the picture here. We don't need to deploy self-encrypting drives. So when you turn on this feature from vSAN, we will encrypt across standard drives that are on the supported hardware compatibility list. So you don't have to have self-encrypting drives. So standard drives that are fully supported for vSAN, OSA, and ESA, you can deploy encryption across any of those. It's fully validated for FIPS 140-2 and 140-3. And yes, yet another acronym. FIPS stands for the Federal Information Processing Standard. So it's fully secured and validated via those standards. In order to enable data at rest encryption, you need to have a key management server. Okay, so there are two that we will look at. There's a key management service that's provided by an external supplier, or we can utilize the vSphere native key provider, NKP. All of this is configured at the cluster level. Now let's take a look at both the KMS and the NKP key providers. So with KMS on the external third-party solution, you'd have to have, obviously, follow the external KMS provider's guidance for installing and configuring. Most, certainly all the KMS providers that I'm aware of, will definitely recommend that you deploy it outside of the vSAN cluster that you are encrypting. Again, we will highlight that over and over again during the webinar. You do not want to create a circular dependency for having your encrypted data and the keys that encrypt the data stored on the same device. That's a really bad idea. So do not do that, please. Okay. In fact, all of the external key providers would recommend that you deploy them in a highly available topology. So that means, obviously 2 of them or maybe 3 of them, and also that they are resilient. So make sure that they are you've got data resilience across sites, for example. So that's how you should really deploy your external key management server. Okay. So those services are great if you want to support data encryption on external devices as well, such as your data backups, or if you've got bare metal. If you're supporting bare metal hardware, then again, you can utilize the same external KMS protection for that. If, however, you do not wish to have that level of encryption, you can use the inbuilt native key provider that's integrated into vCenter. Now, that's included in all vSphere license editions, and no additional hardware or software is required. Okay, and we do support, of course, vSAN data at rest encryption, and we have to have vSphere 7.0 U2 or higher. Okay. Now let's take a look at how we configure external KMS. So as I mentioned earlier on, make sure you follow the guidelines for your external KMS provider and you set that up appropriately with the right levels of resilience for that service. There are different KMIP protocol versions available, but vSAN supports the KMS 1.1 protocol. So look out for that if you're in the market for an external KMS system. Okay, so it's KMS 1.1 is what vSAN supports. Now, we used to have on the VMware software compatibility list, we used to list all of the providers that were supported for vSAN and vSphere from an external KMS perspective. We've recently changed how we do that. So we don't actually provide the actual certification for that. We rely on the third-party KMS provider to do that. So if you're very used to going into a Broadcom or a VMware compatibility list and see a whole list of software, whereas before you'd see a great list of software, now that list is vastly diminished because we've changed the way that we ask our partners to certify. So just bear that in mind. If you are going to go and have an external KMS, the most important thing is make sure that it supports KMS 1.1. and then you're good to go with vSAN. So once the KMS is successfully configured and up and running, we can then start to configure it from within the vSphere. Okay, so we go into vSphere, as the picture shows there, and we'd add our standard key provider. Okay, enter the KMS information, such as KMS, the proxy information and the password protection, the name, the address, and the port. You'd get all of this information from the KMS configuration details when you deployed the KMS service. The second thing what you'd have to do with an external KMS service is to choose a method of trust. Okay, so after you establish the connection, you need to establish trust. And as you can see here, there are 4 different ways of doing that. You have vCenter root CA certificate, a standard vCenter certificate, KMS certificate and private key, and the new certificate sign-in request. Okay, so again, you can choose which way to do this depending on how you've deployed it and what your preference is. On this example here, we've highlighted the fact that we've gone in and used the KMS certificate and private key. Okay, so now let's take a look at the native key provider. So this is the key provider that you can use within vSphere. So again, we would go in to key providers under security and add a native key provider. We would then type in the name of the key provider. That's a name that you will provide, okay, because it's something that you would like to set up. So that's a kind of a free format text field. So you can call it whatever you like. Again, best practice would dictate that you call it something that matches what the service is providing, okay. Notice that we have a checkbox here that says use key provider only with TPM protected ESX hosts. TPM stands for Trusted Platform Module, and we've got a section coming up on that. But again, it's highly advisable that you use trusted platform modules when you have data at rest encryption enabled. And I'll get onto that and explain the reasons why that is in a moment. Okay. And in fact, during the demo later on in this webinar, I'll quickly show you how you can go in and change the key provider. Okay, so it's really straightforward, really simple, and really easy to do that. So once we set up the key provider, we have to do another step. And most importantly, that's back up our key provider. The actual native key provider service will not enable until you've initiated a backup. Okay, so with this backup, it's a good idea to give it a password. It has to be password protected as well. Okay, and again, look here, you have to check the box. I have saved the password in a secure place, because if you ever had to back up vCenter and to reinitiate the key provider, you'd have to get access to the keys again, you'd have to restore with this backed up key provider password and this file that you're going to create. Okay, so it's really, really important that you follow this step, and then you keep the downloaded file somewhere very, very safe. Okay. And as you can see at the bottom, it will say, without this password, access to resources such as encrypted VMs and VMs with virtual TPMs will be lost. Okay. So essentially, if you needed to find this and you couldn't find it, then you'd have to have a good call with our GSS support system to try and get you back online. Okay. Now let's take a look at the keys that are actually used to perform the data at rest encryption. So there are three main keys that are used in this service. The first key is known as the key encryption key, or the KEK. And what's that's used? That's used to encrypt the disk encryption key. And there's typically one per vSAN cluster. Then we come on to the disk encryption key, commonly known as the DEC. And that's used to encrypt the data on the disks. And we can start to see the differences here between vSAN ESA and vSAN OSA. In vSAN ESA, there is one DEC disk encryption key per cluster. In vSAN OSA, there is one DEC per disk. And that's quite a big difference. And later on, when I explain the I/O flow, you'll start to see why vSAN ESA is a lot more efficient at handling data encryption services than OSA. Okay, so we'll come on to that a little bit later, but that's a big difference. And then finally, we have the host encryption key. Okay, host encryption key known as the HEC. So we've got HEC, DEC, and KEK. Wow, I told you this webinar would be acronym crazy. So what does the HEC do? The host encryption key. That's used to encrypt the core dumps when we send your core dumps to VMware support. Typically, there is only one per vSAN cluster, and that key would be generated by the KMS system, KMS server, or the native key provider. Okay. So again, we're going to take a look at the I/O flow in a moment, but it's important to remember that we have three keys: the key encryption key, the disk encryption key, and the host encryption key. Those are the three keys that you need to successfully enable and successfully utilize data at rest and data in transit encryption on vSAN. So now let's take a look at the key workflow. This is really important to understand what's going on and where it's going on and at what point, so you get a full understanding of what keys are used and what they are doing. So the first thing that we'll do, okay, vCenter will generate the KEK, the key encryption key ID, the host ID, and the disk encryption key, okay, for ESA. For OSA, we will have the key provider, KMS, or the native key provider, OSA, generate a key encryption key. So first of all, we get the keys sent. They get sent to all the hosts. That's step number 3. Okay, so vCenter will send the key encryption key to all of the hosts within the vSAN cluster. The hosts will then use the key encryption key to request the KEK from the native key provider or from the KMS. Once we have that, we can then generate the disk encryption key. Now, remember, as I said earlier, vSAN OSA, each host will create a unique disk encryption key for each drive that's within the disk group. For ESA, with KMS, external KMS, the vCenter will generate a wrapped disk encryption key that then gets sent to the hosts. And for ESA with a native key provider, the vCenter will instruct a host to generate a wrapped disk encryption key and return it. So the keys are going around the system. We have the key encryption key. We then have the disk encryption keys. Once we have those, each disk is then encrypted with the appropriate disk encryption key. So as you can see here in step 6, vSAN OSA, unique disk encryption key per disk. vSAN ESA, we have a cluster-wide disk encryption key, so just one key for that. Once that's performed, the disk encryption key and the key encryption key ID are saved to the host. Okay, this is where a trusted platform module really helps. The key encryption key is saved in the trusted platform module if that's available. And also the disk encryption key and key encryption key are kept in memory. Then finally, in step number 8, a host key is generated. Okay, once the host key is generated, again, vCenter would request an external KMS to generate a host key. And if you're using vSAN ESA with an NKP with native key provider, the host will make a request to the key management agent for a host key and it will store it in the config store. Once all of that happens, the hosts will enter crypto safe mode. And there's a slide that we can talk about that later. But that's the process that we use. So if the keys are requested and keys are generated and keys are shared amongst all of the hosts. Once all of the hosts have the correct keys in the correct format, they will then go off and encrypt your data. So how do we do this? Well, data at rest encryption, there's 2 ways that we can enable this. Data at rest encryption can be configured when a new cluster is being built. And of course, that's the recommended time to enable this because there isn't a lot of data within the system. So the actual enabling the actual service, the data at rest encryption, won't take a long time. Okay, so this is where we do it. You go into advanced options when you're going through the cluster wizard and data at rest encryption, you select your key provider and away you go. Very simple, very straightforward. And that's the recommended time to do it. However, you can also enable data at rest encryption on an existing cluster. So there's a couple of things to be aware of here. Okay, the first thing is that when you enable it, okay, and I'll go through the screenshots later on during the demo. It's showing you the screenshots here on the slide. Okay, so you enable data at rest encryption and you will get a couple of warnings. Now, these warnings here will say these settings require all disks to be reformatted. Moving large amounts of stored data might slow and temporarily decrease the performance of the cluster. Now, absolutely, I've got a slide in a moment that will talk about this in more detail. But it's the data will survive, okay, unless you hit the wipe residual data. Okay, so if you hit wipe residual data, it will actually wipe all of the data on the data store. So that's probably not what you want to do. Okay, so if you want to enable data at rest encryption on an existing cluster and you want to keep the data there, you just want to encrypt it, make sure that you just check the box data at rest encryption. Do not check wipe residual data. Otherwise, you'll be in for a very, very bad day. Okay. And it gives you a warning here that the disk format change could fail if there are VMs with an incompatible storage policy. So again, because of the amount of data that's being moved around, it will actually do a rolling disk format. And with vSAN OSA, that rolling disk format is on a per disk group basis. So it will evacuate a disk group, copy the data elsewhere, then encrypt that disk as the data is read back across. Okay, so that process that can take a long time. Clearly, it all depends on how much data that you have to encrypt. But if you're talking terabytes and terabytes of data, then this process could potentially take weeks. Okay, so just be cautious, be careful about turning this on an existing cluster. Okay, just be sure you understand the implications of doing so. Okay. Now, the operational impact when activating encryption. Now, we use different disk formats, so there will be a rolling disk format. Okay, so as I've mentioned before, that rolling disk format on ESA, it's on a per disk. On vSAN OSA, it's per disk group. Okay, so before you turn this on an existing cluster, make sure that you have enough free capacity to perform those disk evacuations. Okay, because all of that data will be read off and then read back on. So you're going to have some swing space, some free capacity on the cluster to enable this. Second point is to make sure that there's no vSAN resync operations that are running in the background. Because again, because there's going to be a lot of back-end traffic that the rolling disk format will need. So if there's any resync operations, then that's just going to slow things down even more. Third point, ensure that the cluster is in a healthy state before you try anything. Again, that's almost common sense, but again, just make sure that everything is okay and everything is green before you turn this on. Here's another good point, schedule activation outside of production hours. Well, again, because of the amount of back-end IO traffic that's going to be generated, then it will affect the actual live applications that you're running. And it says here outside of production hours, but that's kind of assuming that the process will finish, in a 12-hour window outside of a regular 9 to 5 perhaps. But don't forget, if you've got massive data stores with terabytes and terabytes of data, then that process will take more than 12 hours, absolutely. And it's a really good idea to monitor CPU and memory both before and after you turn this feature on. And again, if you've got a cluster that's running low of resource from a CPU and memory perspective, then you might want to think twice about turning on data at rest encryption. Again, simply because data at rest encryption, like any other data service, will need some extra resource to run it. Okay. And again, that applies whether it's running on vSAN or any third-party storage. Okay. So just make sure that the cluster has got enough free CPU and memory to enable this feature to run properly. Okay. Okay, so now let's switch gears and take a look at vSAN OSA, the IO flow. So the guest will send, step number one, OS will send writes to commit to the disk. Step number two, vSAN will encrypt the data using the cache's disk encryption key, and encrypted data is committed to the cache disk. When the data needs to be destaged, the vSAN will then decrypt the data. The data is then re-encrypted using the capacity disk encryption key and stored onto the capacity tier. So you can see here with vSAN OSA that the actual data gets de-encrypted and re-encrypted twice, because we're destaging from the cache tier in step number 2 down to the capacity tier in step number 4. So again, that's why vSAN OSA, you would need a little bit more resource to successfully enable data at rest encryption because of these extra steps, because of the caching from the D stage from the cache disk down to the capacity disk. Now let's see how that same workflow operates with vSAN ESA. Now remember with vSAN ESA, because we've got a single disk encryption key that goes across the entire cluster, data is only encrypted once. So on step number 1, the guest OS sends a write to commit to disk. First of all, on vSAN ESA, we will compress the data. Okay. Then we will encrypt the data, and then the data is written to the performance leg of the vSAN ESA. Okay, or directly to the capacity leg if it's already in a full stripe. So it's far more efficient. Okay, so it will still take resources, but it's far more efficient to enable data at rest encryption when using vSAN ESA. Okay, and as you can see here, it's very, very efficient because compression and encryption are performed before data is sent across the vSAN network. So those internode communications on vSAN will be, the traffic there, the traffic flow will be highly efficient. Let's now take a look at vSAN encryption, the CLI. So on the CLI, we have a couple of commands here, ESX CLI vSAN encryption get and KMS list. So those are a couple of commands that you can run from the CLI that will give you information on what type of encryption you're using, if the keys are enabled, etc., etc. You'll also see the key IDs there as well. Okay, so again, it could be worth taking a look at these on a regular case. Now let's take a look at the boot up process. So number one, the host boots up. Okay, so the KMS boots up, the host boots up. The host will reach out to the KMS or the NKP to get the KEK. Okay, once the host has the KEK, it will then decrypt using the disk encryption key. Then the disks are mounted and data can be written and read using the disk encryption key. Okay, so that's the actual process that we use for when a host is booting up. Now, I mentioned earlier on about trusted platform modules. Trusted platform modules are absolutely recommended to be used when you enable data at rest encryption, because they act as an additional layer of hardware that will host and keep the key secure. In fact, TPMs they're quite cheap. They're under $5 or $6, I believe, on when you're buying a server. And I actually now believe that some server vendors are including TPMs by default as part of the build. So if you've got access to TPMs, then absolutely utilize those, because they will store all of the encryption keys locally. There's a really good point at the bottom of the picture. If the TPM isn't installed and the native key provider or the KMS server is not available, then the hosts can't mount their disks. Now, in that scenario, do not reboot. If you haven't got access to your key provider service, whether it's NKP or KMS, then don't panic. Okay, if your servers are still running, then they're getting all of the encryption keys from the TPM. Okay, so at that point, if you can't access your native key provider or the KMS, then do not reboot your servers. Do not reboot your servers. Otherwise, they will not be able to mount their data stores. And again, that wouldn't be a very good day. Okay, so to help you with that, make sure you've got TPMs installed and they're operational. So now let's take a look at how a host will boot up when we have the trusted platform modules installed. Host boots up, TPM accesses the key encryption key. The host will use the key encryption key to unwrap the disk encryption key. The disks are mounted and vSAN is ready. So very, very important. When you enable disk data at rest encryption, you have to enable encrypted vSAN core dumps. So as you know, ESXi, when it crashes, it will create a core dump. So the core dump is the working memory of the ESXi host. So this will allow our support team to understand what was happening. So with vSAN data at rest encryption, the ESXi host stores encryption keys in memory. So these memories are stored in clear text. Okay, so this could create a security concern as and when the core dumps and logs are sent to VMware support. Okay, so we can actually encrypt the actual logs as well. So we can actually encrypt the core dumps by using the host encryption key. So we can encrypt those so it's now encrypted. When we do that, it's considered to be in crypto safe mode. And to verify that, we will just go into the cluster, go into configure, have a look at the security profile, and make sure the host encryption mode is enabled. Very simple, very straightforward. When we export our system logs, the core dump logs, we will have to put a password on there for encrypted core dumps. You put the password on, and then you can directly upload the files, and they're safe and secure. Okay. Don't forget to share the password though with VMware support, otherwise they will not be able to access those very important logs. Now let's take a look at data in rest encryption, the key management. Okay, so data in rest encryption has to be actively managed. Okay, so it's not one of these things that you can just turn off and forget. Okay, so from time to time, you will need to generate new encryption keys. So check with your security team as and when they think it would be a good time to schedule a regeneration of new encryption keys. Okay, maybe if an administrator leaves, that might be a good point to actually re-encrypt the data. Okay, so there are a couple of things to look out for there. So to generate new encryption keys is very simple, very straightforward. First of all, we'll do a shallow rekey. So a shallow rekey that only rotates the key encryption key. It's very fast, it's painless, it doesn't do any disk formatting, it doesn't shuffle any data around, it's very quick, it's very easy. Typically, doing or regenerating a new key encryption key is typically the only thing that you'd need to do. Okay, if you had to generate a new disk encryption key, then again, that is going to re-encrypt all the data on the disks. And again, that's going to take a process, an amount of time to complete. So we do a shallow rekey, or as I just mentioned, we can do a deep rekey. Okay, so a deep rekey would absolutely re-encrypt all of the data. And that's a time-intensive and a very resource-intensive process. Okay, so just bear that in mind. And again, you do get warnings about this, but just bear in mind it's a non-trivial task. So typically, you would only regenerate the key encryption key unless you really, really, really had to do a deep rekey again. Okay, within this Skyline Health and within vSAN, we can also alert you as to when keys are expiring. So we can set an expiry date on keys. And again, this is just to make sure that you're in compliance with your security operations, to make sure that that the keys are actually, we can give you a warning to let you know that it's time to maybe replace the keys. Now let's take a look at data in transit encryption. So again, data in transit encryption will use a secure TLS session, and it will set up a secure TLS session between all of the nodes within the vSAN cluster. Okay, so you'd set that up. It uses message authentication for data authentication and data integrity, and it supports a native proprietary technique to encrypt the vSAN traffic. It's very simple and very easy to set up, and I'll go through this in a moment during the demonstration. You also get a different rekey interval, okay? And again, you can rekey every day or every month. It's entirely up to yourselves. And again, refer to your security team to select the best policy that suits your environment. So the data in transit encryption workflow is a little bit different. So step number one, we will create a TLS link between the vSAN hosts intended to exchange traffic. Then we will create a shared secret and attach that to the current session, and use the shared secret to establish an authenticated encryption session between the vSAN hosts. So now we are fully encrypted. We are encrypting data at rest in transit. So that's giving you extra security across the network communications between your vSAN cluster, between the nodes within the vSAN cluster. When it's turned on, all vSAN host-to-host communications are encrypted. Okay, so all non-data traffic is encrypted, as well as all of the compression and all of the data traffic that's sent across the vSAN network between the hosts. That's all encrypted. So let's now have a quick demo. So I'm utilizing vSAN Hands-on Lab to show you a quick demonstration on how to enable and disable data at rest encryption and how to do a shallow and a deep rekey. So we go to the cluster here and we go to data services for vSAN, services and data services. Here we can see data at rest encryption is already enabled. When you start this lab, data at rest encryption is enabled by default. We're also using the native key provider, and it's under the name of NK1 here. And as you can see, it's a hypertext link, so I can click on here and I can go to NK1 and just check that it is actually active and it's been backed up. And we can also get a copy here of the key ID. Okay, so that's all good. That's exactly what I'd expect to see. From this screen also, you can take another backup. Okay, so let's just click back up here and it will say protect it with a password. And the password here we can show, which is the standard Hands-on Labs password. If you've used Hands-on Labs, this password is well known. And then we'll save this to a secure place and we'll back up the key provider. Okay, as you can see here, it's generated a file that we can then download and copy off to somewhere safe. Okay, we'd also use this screen if we needed to do a restore. So if we hit restore, okay, is already, okay, so it's saying we can't do a restore because there's one active already. Okay, fine, not a problem. Right, so now what we'll do is we'll do a shallow rekey operation. So if I go back to the region here, to the cluster, and generate new encryption keys. So remember, a shallow rekey does not take a lot of time. Okay, so we get a warning here, all encryption keys on the key management server cluster are regenerated. And it says also re-encrypt all data on the storage using the new keys. Now that would be a deep rekey. We do not want to do that, not intentionally anyway. So I'm just going to do a shallow rekey, but just be aware that it says that all encryption keys are going to be regenerated, but that's not really true, is it? As we've seen during the module earlier, that's only the key encryption key. So that's going to take a minimal amount of time, and there's not going to be any disk reformat or any data resyncs or moving of any data on the back end. So let's click generate. And as you can see here, if I pull this tab up higher, update vSAN configuration, regeneration of new keys, completed. It's essentially done in a matter of seconds. Okay, so that was generating a shallow rekey. So don't forget, all we've done there is we've regenerated the key encryption key. Okay, so now let's do something else that's very quick and very easy. Let's go in and let's turn on data in transit encryption. So data in transit encryption, we'll turn that on. We'll do a rekey interval of every 7 days. And we just click apply. And again, because we're going to be creating secure sockets, secure connections between our vSAN nodes, there's no data to move or anything like that. So it's a really quick and simple operation. So again, it's not quite as quick as a shallow rekey, but it's getting there. As we can see here, it's updating the vSAN configuration. And it's done. Okay, so we now have enabled data services of data at rest encryption, but data in transit encryption as well. And we can see the confirmation of it there. Okay, finally, what I'm going to show is the back-end performance of if we had to do a deep rekey. Now, remember, a deep rekey is replacing all of it's going to reformat the disks and re-encrypt the data using the new disk encryption key. So I go into edit here, and that's not where I want to go, is it? I want to generate new encryption keys. That's the one I wanted to press. So now I will check the also re-encrypt all data. Re-encryption temporarily decreases the performance of the cluster. Okay, this is a hands-on lab. I'm not too bothered about that. But if this was a live production server, then yeah, perhaps I would pause for thought at this point. But I'm going to go ahead and click generate. And let's see now. Let's see, make sure the tasks are running. Okay, so the tasks are running. Okay, here you can see the disk format has started. Okay, so now if I bring this down, wrong one. Very tricky. Okay, let's take a look now at the vSAN performance on the back end. And hopefully we should see a lot of back-end traffic. Yep, as we can see here, the latency is starting to creep up, as is expected. It's expected to do that because we've asked the vSAN cluster to do a rolling disk format. So we're running ESA here in this lab. So it's going to be going across and reformatting every single drive one at a time. Okay. So again, we would expect this traffic to go up. We can actually double check that by taking a look at the back end, okay, for vSAN. And as you can see there, the IOPS has started to increase. And this process will probably take around about an hour to reformat the disks, okay? And as we can see here as well, the throughput is going up through the roof. So we've got a resync read going on at the moment. And this is all because we're doing now a deep rekey of our vSAN data store. Okay, well, that concludes the demonstration. I hope it's been valuable for you. Thank you.
So as usual, can you please complete the survey? It's really, really useful for us in choosing the next topic, which we're going to cover. We will send out the Zoom invite for the next session, which will be on Friday, the 25th of July, probably in a couple of weeks. Actually, Ian, if you can just go back onto that next slide as well, that would be great. Just want to call out that we've got, and I know sort of apologies for people who followed previously, but I'm just conscious that we get different attendees joining for different sessions. We've got the VMware UserCon is in London on the 18th of September in the Hilton Metropole Hotel. So I would really recommend registering for that. You do need to register to be able to attend that session. And also, if there's a call for papers, so if there's something which you've been working on based on VMware technologies, which has worked really well in your business, or something which you thought was very useful in reducing the time and effort, then feel free to post a call for papers. It's a great way for to be able to share knowledge, and also good for the for your personal brand and sort of knowledge within the wider community. So finally, on behalf of the UK&I Solution Architecture team, thank you very much for joining us today, and we will see you in a month. So have a great weekend, everyone. Thank you. Bye-bye.
Thank you.